So let us start our lecture in continuation, part 3. Surface air. All materials carry a surface layer of air. When films are slit and rewound, the air is carried to the rewound roll. At low speeds, this layer of air can escape at the ends of the slit rolls without causing problems in winding. At high speeds, air is rewound into the roll. This can result in the air acting as a lubricant, or it is trapped between the layers of materials. When air acts as a lubricant, it allows shifting of the second, third, and lower layers. Air bond between layers showing the relative shifting of the material. When air is trapped between the layers of materials and is wound into the roll, it forms balloons, bubbles, causing deformation and occupying volume as a secondary layer as shown in the picture next or the figure. This causes poor roll formation and deformation of the web. Dual Duro touch rolls help minimize air entrapment and gauge variation issues when, when rewinding film. Beside foams and films, the, the pressure sensitivities, foils, indoor products, and self-wound products. Additional features facilitate ease of use. A short web path from slip to rewound simplifies cutoff and stand alignment at the core. Splitting setup is easily accessible and at a convenient height for operators. Air entrapment. Air that is introduced into the fluid prior to the coating head is entrapped. I remember the term by thinking about the fact that the bubble is already on the train track before it enters the coating head. Temperature and pressure also can be your friends. If the process and materials allow, you can heat up the fluid and pull a vacuum. In case of BOPP tape, it is not possible. As the coating head is positioned for a better seal, the air introduced becomes more of a minor defect that may be noticeable only on the final coating product. Even with full coating, however, the improper seal of adhesive to the substrate or bonding of adhesive to the substrate may lead to fluid flow changes in the coating lead. Now let us see something about central winding. On some materials, contact pressure cannot be applied because the materials could become blocked or damaged. Here, central winding becomes necessary. Today, central winding is the most prevalent type of winding, and the basic principles remain the same whether the operation takes place in a vacuum or in ordinary atmosphere or in the pressurized chamber. As far as BOP tapes are concerned, it is done in ordinary atmosphere. In central winding, the winding forces are derived solely from the rewind shaft and is transmitted to the winding web through the core and layers of material that have already been rewound. The winding force is generated by the DC motor or the drive. Here is a typical example of central winding, a duplex winder, a typical slating machine that we use for BOPP tapes, and this is a cross section of a slating machine, you may say. This is how the roll gets rewound after cutting. The reduction in tension as web diameter increases during the winding is desirable. Central surface winding. You can have a combination of central winding and surface winding, and this is how it can be done. Central winding duplex winders, the figure shown earlier is self-explanatory. Generally, 3-inch ID cores are used. The maximum diameters that could be wound on this duplex winder could be 12 to 14 inches, depending upon the type of the machine or the type of system. Central winding is the easiest to wind at constant torque. When it is necessary to wind to larger diameters on a given core size, program torque is used. It is seldom advisable to attempt constant tension winding in a central wind operation. The bottom line figure shows the basic constant torque decreasing tension curve. Now, this is a graph. It is showing the, the tension against the diameter, effect of different tensions in central winding. Now you see the first line on the top. If the tension is constant, the graph or the line is straight. If the weight tension when the torque is increasing as the process progresses, you can see a different graph. And if the web tension, it is throughout constant, then the graph can fall down. Individual top riding roles. Being constantly aware of obligations to provide equipment capable of satisfactory winding at high speed, the individual top riding roles for multiple role splitting was developed as still another refinement to an already production proven and versatile piece of equipment. This is how in this figure you can see what is meant by top riding roles. This is how we can control or we can install a top riding role which will help in removing entrapped air totally. The incoming wave is guided precisely to and brought into contact with the rewinding rolls so that the side shift and weaving are eliminated and individual rolls are not affected by off-gauge condition of materials in adjacent rolls. In wind tension from a winding nip, a benefit. Here you see a diagram, uh, of a combination of surface and central winding. This is how it can help a lot. It may be a benefit, but mostly it is important to understand when it increases roller tightness and when it does not. The benefit of nip induced tension is that it can reduce the tension that must be transmitted through a center winding rope. Too much center torque can lead to clenching and telescoping. Winding nip tension can create a tighter roll without these defects. What is the best geometry for winding nip? Answer: there should be some wrap in the winding nip so the web is placed onto the roll by the nip. If the whip touches the roll, then letter is nip. Some of the anti-wrinkle and improved tracking benefits are lost. A winding nip after the whip timing point still will have some air squeeze and induced tension benefits. The best winding nip geometry is a 180-degree wrap. This does two things. First, it orients web tension perpendicular to winding nip force, making the winding nip load independent of tension. Second, if the winding nip roll defects or screws, a 180-degree nip wrap ensures it will be perpendicular to the entry span, reducing the likelihood of tracking or wrinkling. What is the gap winding? Now here is a picture. You will be able to see what is meant by gap winding. A gap winding is similar to a nip winding, but it does not contact or load against the roll. Instead, as the name implies, the gap winding positions the final roll at a small gap from the winding roll's outer surface, creating an extremely short entry span. What are the benefits of a gap roll relative to a winding nip? You can see the winding which is very square. This is what is designed to minimize the trim losses. A gap roll has the same anti-wrinkle and improved tracking benefits of a pack roll. However, since it does not create pressure or force on the outer layer, there is no air squeeze or nip induced tension benefits. Individual top riding rolls are used to obtain straight, smooth-sided rebound rolls at high and low speed when winding off gauge, high slip, light tension problem materials like films. Of all the process which has been made with regard to the slitting and rewinding of these materials, the development of an individual top riding roll for each individual rebound roll is probably the best outstanding engineering advance. Efficient subsequent operations to a large extent depend on the smooth edged even density rolls of packing materials which can be produced on slitting rewinding equipment. Four major factors must be compensated for in order to produce the desired slit and rebound roll. These factors are gauge variation, gauge bands, slick zones, and entrapped surface air, which acts as a lubricant when an excessive amount is trapped and wound their within their wound rolls. All materials carry a surface air layer with them as they move through a machine. When films are slit and rewound, this air layer is carried towards and partially into the rewound roll. At low machine speeds, most of this air layer can escape as the wave enters the rewound roll without causing a problem in winding. However, at high speed, an excessive amount of air enters the roll and this results in two conditions. Number one, air becomes a lubricant and acts as a frictionless separator between the layers of material, allowing shifting of second, third, and low layers within the roll. Number two, air is trapped between the layers of the material and is wound into the roll. Once inside the rewound roll, it forms tiles or balloons or bubbles which can have various detrimental effects depending upon the characteristics required of the finished roll. The top riding rolls may be 3-inch ID paper core mounted on two flange ball bearings in the turn mounted on aluminum tubular central shaft. These are held in position by easily removable arms and are quickly changed from one weight to another by simply changing the paper core or the whole assembly. For maximum utilization of these individual top riding rolls, it is necessary to have the incoming wave enter into contact with the rewinding roll at the point of contact with the individual top riding roll, or better yet, to wrap around the top riding roll. It is incoming if the incoming web contacts the rewind roll some distance ahead of the individual top riding roll, the tracking and guiding effect on the top riding roll is lost. So it should not get in contact prior to the contact at the top riding roll position. Once this has occurred, it is extremely difficult, if not impossible, to force the air out. Leon rolls. They are nothing but the top riding rolls. Leon rolls are manufactured and used to help reduce air entrapment when winding. Leon rolls are manufactured and used to help reduce air entrapment while winding. They are utilized within the paper, film, foil, or plastic industries. The benefits: higher speeds on web processing and machine with tighter parent roll properties. Best used for they are utilized within the paper, film, foil, and plastic industry. Winding better rolls. It is not obvious low winding adds value to your product. It does, but it is obvious when it's done poorly. Winding. It seems so enough, but done poorly, winding can turn 100% good products into waste very quickly. One key to quality wound rolls is the winding nip. The winding nip is a roller driven or idling that remains in contact with the winding roll throughout its build-up. The winding nip has many aliases including Leon roll, pack roll, surface roll, and contact roll. Some of The same rule quality benefits also are found using a close cousin of winding nip, the gap rule. Are winding nip rules used in both surface and central winding? Yes, winding nip rules are used in both. You cannot have a surface winding without a winding rule. It is a necessity. Adding a winding nip to a central winder improves the rule quality. The rule, which is the most common, surface or central winding. If you survey winding equipment shown at the CMM show, the exhibition, central winding dominates the converting industry even today. This dominance is not because it is the best winding method, but because it is simpler to build and easier to automate rule transfers. In the paper industry, you will see more surface winding for two reasons. Also in film industry, first, paper roll properties allow winding to extremely large diameter built-up ratios, where the final roll diameter may be 20x the core diameter. If tensioning torque is generated from the roll's center, the dimension of central winding, the torque required tension versus radius will have a torque range impossible for most motors. Surface winding takes roll diameter out of the torque range requirement. Second, many paper winders use a simple rip and tuck roll transfer. If there is a core start wrinkle, the soft paper layers quickly mask them. You could never do a rip and tuck with films or foils without a lot of wastage from wrinkles and impressions. So central winding and automated transfers are preferred. Why does winding nip improves roll quality? You see the benefits here in the picture. The entrapment air, which is shown on the top, is removed with help of or reduced with help of winding air volume. This is shown in round cross section of the roll. You can see that uh, in the flat position, uneven side escape can drive the wave laterally. In the bottom picture, you can see wave roll friction easily opposes reactive motion. Winding nips do a better job of managing the wave's last span and initial contact onto the winding roll. Mismanagement of the wave's final span before winding is like the poor grocery beggar. What are the benefits of a winding nip? The winding nip has four main functions. First, it reduces the span length into the winding roll, reducing tracking errors and wrinkling. Second, it acts as a squeeze, reducing the air entering into the winding roll or entrap into the roll. Third, it tends to form more cylindrical roll. Finally, it tightens the winding roll. How does the winding end span length promote tracking and wrinkling effect? The three sources of wave tracking error are misaligned, diameter variations, and wave bagginess. Winding rules can have one or all these errors, especially dimension or especially diameter variation. Because the web's flexibility goes up with the span length cube, the magnitude of tracking error from these sources will increase with longer entry spans. What is an example of span length increasing tracking error? Many turret winders have wrinkles and tracking errors during the index cycle. Many turret winders have wrinkles and tracking errors during the index cycle. Entry-level turret winders have a winding nip in the primary winding position, but the nip does not contact the rules once the index cycle begins.